differential equations question, except we're actually given the solution to the differential equation and we're being asked to get back to it at a later point. But let's just start with, so n is the number of mice in the population, t is the number of months after the study, and we're asked to find the number of mice at the start of the study. So that is going to be when t is 0. So I'll get n is equal to 900 over 3 plus 7 times e to the 0, which is just 1. So it becomes 900 divided by 10, 90. I would say even if this is the last question in the paper, that mark is achievable, like, and even if you struggle with this sort of question. Okay, so don't just give up and think I'm only going to do the first few, first half of the paper, even though you might concentrate on that. This is just if you're struggling with any aspects of the A level, there's still marks to be had later on, even if the next bit is going to be a bit trickier. So we're now asked to find, well, to show that dn by dt is this. I'm going to need to differentiate, but kind of bear in mind n at the same time. Okay. So first up, I mean, I could in theory use the quotient rule, but I'm not going to do that. Because there's a constant at the top. Instead, I'm going to write it as 900 times 3 plus 7 e to the minus 0.25t, and then put it all to the minus 1. So now I use the chain rule. I'm going to go ahead and use the inside-outside version of the chain rule. So essentially, I have a something to the power of minus 1 function. That's what I mean by the outside. So it's going to become minus whatever I have, and just keep it exactly the same, because I'm bringing that minus 1 down. And then I'm going to be raising that to the power of minus 2, going to decrease the power. And I times by the derivative of the inside. So the 3 disappears, but I'm going to get 7 e to the minus 0.25t, and then times by minus 0.25. That is the derivative of this function here. The e just stays the same, the 7 kind of passes through, but then we times by minus 0.025. If you need to, or if you prefer, you can let u equal 3 plus 7 e to the minus 0.25t, and then n would equal 900 u to the minus 1. And then you can do dn by dt is dn by du, du by dt. So dn by du is exactly what we got here, because when you put it back in for u, you'll get that 3 plus etc. back. And then the du by dt is exactly the inside. So that's why I'd say, you know, practice it. Practice the inside-outside version. It's just a bit quicker. But if you prefer, of course, use the substitution. I'm not going to say definitely don't do that. Right. We now need to, okay, think about what we actually have. We've got to try and show that dn by dt is this. I just need to get all of this back in terms of n now. Well, n over 900, see, I can see I've got this like 3 plus 7 e to the minus 0.25t to the minus 1 being squared. So if I write n over 900 equals exactly that, and this implies that dn by dt is going to equal 900 multiplied by n over 900 squared. Oh, sorry, there's a minus in there as well. I'll put a minus there. Yeah, that is this thing squared, actually. So I've just replaced it all by n over 900. And then I'm timesing by what's going to become minus 7 over 4, because that's that minus 0.25, e to the minus 0.25t. Right, let's just tidy this up. Actually, there's two negatives, and the 900 is going to partially cancel, so I'll be left with n squared over 900 times 7 over 4 e to the minus 0.25t. Now I really need to sort out that exponential. So what we can say is that 900 over n is actually going to then equal, I'm just swapping them around. That's going to equal 3 plus 7 e to the minus 0.25t. And then I can minus 3 from both sides. So I will get this here. Okay, and that's going to sort me out with my next line. dn by dt will equal n squared over 900 times, and then I'm going to replace, I kind of wish I hadn't done, so I'm going to put the quarter here, and then I can replace this by 900 over n minus 3. Let's just keep track of what we're actually trying to get to. Okay. Keep the 1 over 4 for the moment separate. Then I'm going to multiply through by n. Like so I'm going to have n over 100 and then times by 900 minus 3n. And then I can write n 900 minus 3n all over 4 times 900, bringing that together. I can divide the top by 3, which will make it 300 minus n. Divide the bottom by 3, which will make it 4 times 300, or 1,200. And it's come together. It's definitely a bit fiddly. Got to say that. That's not the only way to do it, but you're going to have to somehow, once you've done your differentiation, somehow replace, where's it gone? Oh, up here, replace all these exponentials by n, and I think the way I did it is a pretty good shout. Now, some final parts. The rate of growth is a maximum after t months. So that is actually the rate of the rate. We've got two ways we could do this. We could either differentiate again and set it equal to 0, and I'm tempted to, I'm definitely going to do it that way to show you. So that means the second derivative will equal 300 minus 2n over 1,200. If I set it equal to 0 for a maximum or stationary point, then I can just times through by 1,200. It's going to be when n is 150. Now, then we have to put that back into the original equation to work out t, which I'll do in a second. The other way you can do it without actually doing the second derivative is to draw a little graph of the derivative itself. So there's going to be, when n is 0, the derivative is going to be 0. When n is 300, it's going to be 0. Then it's a negative quadratic, actually. And we can use the symmetry of the curve to see that the maximum rate of growth dn by dt up here is going to be at 150. So that's your alternative way to do it. So now we put it 150 into here. This is still part C, continued. I'm just sorry, I'm kind of moving around all over the place because this is where the equation is. So 150 is 900. So I can times through by 3 plus 7 e to the minus 0.25t and divide by 150. So I get 900 divided by 150, which is 6. Therefore, e to the minus 0.25t. I can minus the 3 and then divide through by 7. So I get 3/7, which means minus, I can do ln of both sides, which is going to give me minus 0.25t is ln 3/7. Put that in my calculator, which gives, and it's capital, so I'll call it capital T now, is 3.39 months. One more question to contend with. According to the model, the maximum number of mice on the island is p. State the value of p. So the maximum number is going to be when dn by dt is equal to 0. That's going to be our stationary point. So it's when this is 0. It's clearly not going to be n is 0. It's going to be n is 300. Now the answers say 299 or 300. And I think it's getting at the fact that it's going to converge towards 300. So we're never quite going to get that actual maximum. If you look at the exponential here, it's going to be when, it's going to be when this term essentially is when time gets really big, that term will go to 0, and therefore we'll get 300, 900 divided by 3, although we're never going to quite get there. So you might say 299, but 300 is allowed in the answers. And I think, essentially we're converging towards it. So we can round up to 300 and say we would have 300 mice essentially. Okay, well done on this question. There's plenty of challenges going on in it. I hope my explanation makes sense and that, you're happy with it.